get started in a minute. Okay, alright. So I'm just listening to some stuff from the YouTube audio library. It's pretty good actually. But I don't think my audio capture is working anyway. Yeah, I don't think it is. So I'm going to turn this down a little bit. Doesn't work. It's a bit loud for me. Don't know. I think prefer the silence. Okay. So still really hot. So we're going to carry on with learning eLisp. Now, originally the idea of this series was to go through the eLisp exercises on exorcism, but the exercises on exorcism are kind of interesting. They really are just exercises with no hand holding. So I think the idea is that you are going to go and learn this stuff yourself and then complete the exercises. So we're now going through the eLisp introduction, the introduction to Emacs Lisp, through Emacs's info pages. So last week I had these questions and comments that I collected. So this is just stuff that I keep track of when I read something and I don't quite understand what the hell it's talking about. I write it down as a to-do in org mode, and I think each stream I'm just gonna read back over it, refresh my memory of what I didn't get, go over what I did get to remind myself what the solution I found was. So yeah, let's just go quickly through what I got so far. So if we have a single apostrophe before a list, it causes that list to return just as a list. So the list as is will return from evaluating that. Whereas if it doesn't have that single apostrophe, we end up treating the first item in the list as a command. So this can cause problems if you pass a list without a apostrophe, and the first item in the list is not a known command. So this is one of the things that confused me initially. So what was happening was when you evaluate an expression, you put your cursor at the end, just after the final bracket. You evaluate it. Okay. I can't evaluate like that in org mode. I might have to look up how to evaluate within org mode, but I can do this instead. I think. Yep. No, I can't. Okay. Interesting. I assumed that would put me into Emacs Lisp mode, but apparently it did not. Anyway, if you evaluate it from the final parentheses, it will give you whatever the result of what's inside the parentheses is, the list. But what I was confused about was if I put the cursor here and evaluated it, I got 2. So I put the cursor here, I got 2, because plus 2 is positive 2. And then if I put it here, I get 2 as well. I was a little confused about that. The reason for that was that if you put it after a number, for whatever reason, it just returns that number. So if you evaluate just a number on its own, it just returns that number. So that was that mystery. And then we had two-faced symbols. So symbols can have both a function definition and a value attached to it. So essentially something can act, you can have a function, no, you can have a symbol that links to a function, or a symbol that links to like a variable, essentially a value. So it acts like a variable, or it can act like a function. And this was really confusing to me. But what I realized is probably the way this works is when you get a list, then you get the list of those things in there, the values of the variables in that list, or the symbols in that list. So if you just want to get those back and evaluate those and return the values stored in those symbols, then you get the values. You know, going back to that apostrophe thing, the single apostrophe, if you do the single apostrophe, it treats it as just a list, and if you do a double apostrophe, then it does ooh, what's going on with the stream? That's weird. Hang on a minute. There's something very odd going on with the stream at the moment. I hope I'm live. That's really odd. Yep, okay, it looks like I'm live. Okay. Give me 1 second to correct some things about the stream. We've just had a weird mishap. Maybe I didn't refresh a page or something. So I'm just gonna edit this to be what it should be. So this is not Anki. We're doing Emacs, yeah. So if anybody joined the stream wondering why I was doing Emacs Lisp instead of Anki, like the it's not working. Like the description and the title of the stream said, the reason is that something screwed up and it ended up doing the wrong name. Okay, we're halfway there. Alright, I'm just correcting the stream title and the stream thumbnails and everything. Oh no, now I've really screwed it up. Now I've screwed up the other one. Alright, third time's the charm. Give me 1 second. So we want to turn this into this. Good. And then turn this into this. Just need to change the thumbnail and we should be good. Sorry about the interruption. Okay, so back to where I was. So yeah, so if you evaluate the list with like an apostrophe in front of it, then it's going to just return the list. But then if you evaluate that list without the apostrophe, then the first thing is a command. So presumably the command, the function that is linked to a symbol will execute in that case, whereas the value is stored in the list if it's, you know, evaluated with an apostrophe in front of it. So I guess that's the reason for that difference. I haven't seen a use case for this yet, but it'll be interesting to find one. I guess you can then iterate over the values in the list if you return it with the apostrophe. Yeah, it's interesting. I don't know why they do it like this, but I assume it's some kind of function that we're going to find out about. I just accidentally switched to caps lock, but then that reminded me that I was typing the Chinese input. It's not very good Chinese input, but it helped me out in a fix. What was my original input? R or something. It was like R. RFC something. Yeah. There we go. Yep. Okay, so we're just going to keep going. So I think I've understood that, so I'm going to mark it as done, and we're going to keep going with the Emacs Lisp. So error message for a symbol without a value. If you attempt to evaluate a symbol that does not have a value bound to it, you will receive an error message. You can see this by experimenting with our 2+2 addition. In the following expression, put your cursor right after the plus before the number 2, type Control-X, Control-E. You'll create a backtrace buffer that says blah blah blah. Again, you can quit the debugger. I better read it out just in case you can't see it. Buffer, backtrace, debugger, entered, Lisp error, void variable, plus symbol, eval plus, eval last, special symbolic expression 1, nil, eval last, special expression nil, call interactively, eval last, symbolic expression, buffer backtrace. Again, you can quit the debugger by typing Q in the backtrace buffer. This backtrace is different from the very first error message we saw, which said debugger entered Lisp error void function this. In this case, the function does not have a value as a variable, while in the other error message, the function, the word this, did not have a definition. This backtrace is different from the very first error message we saw, which said debugger entered Lisp error void function this. In this case, the function does not have a value as a variable. Oh, I understand. So when we evaluate just the plus on its own, we're evaluating the value of the variable. So that's why when we evaluate just a number on its own, we get the number back, because that's the value of the symbol. in this experiment with the plus, what we did was cause the Lisp interpreter to evaluate the plus and look for the value of the variable instead of the function definition. We did this by placing the cursor right after the symbol rather than after the parentheses of the enclosing list as we did before. As a consequence, the Lisp interpreter evaluated the preceding S expression, which in this case was plus by itself. I see. So what would happen if we put it inside a Lisp just on its own? We get 0. That's pretty interesting. Kind of intuitive, I suppose. Okay. Since plus does not have a value bound to it, just the function definition, the error message reported that the symbol's value as a variable was void. Yeah, okay, that makes sense. Alright, arguments. To see how information is passed to function, let's look again at our old standby, the addition of 2 plus 2. In Lisp, this is written as follows, plus 2, 2. If you evaluate this expression, the number 4 will appear in your echo area. What the Lisp interpreter does is add the numbers that follow the plus. The numbers added by plus are called the arguments of the function, so you pass arguments within the list. The numbers these numbers are the information is given to or passed to the function. The word argument comes from the way it is used in mathematics and does not refer to a disputation between two people. Instead, it refers to the information presented to the function, in this case to the plus. In Lisp, the arguments to a function are the atoms or lists that follow the function. The values returned by the evaluation of these atoms or lists are passed to the function. Okay. Different functions require different number of arguments. Some functions require none at all. So the process is that the symbols in the list are evaluated to their values and then passed as arguments. Those values are passed as arguments to the function. Okay. What happens if I do 2 plus 2 in the wrong order? Yeah, okay, debug it into invalid function 2. Yeah, okay, so it just doesn't like that format. It doesn't sort of try and accommodate it. Okay. Footnotes. It is curious to track the path by which the word argument came to have two different meanings, one in mathematics and the other in everyday English. According to the Oxford English Dictionary, the word derives from the Latin for to make clear, prove. Thus it came to mean, by one thread of derivation, the evidence offered as proof, which is to say the information offered, which led to its meaning in Lisp. But in the other thread of derivation, it came to mean to assert in a manner against which others may make counter-assertions, which led to the meaning of the word as a disputation. Note here that the English word has two different definitions attached to it at the same time. By contrast, in Emacs Lisp, a symbol cannot have two different function definitions at the same time. Okay. Interesting analogy, I suppose. Actually, let me just. Oops. Just want to check something. Hey. What the? That's weird. Yeah, okay. The type of data that should be passed to a function depends on what kind of information it uses. The arguments to a function such as plus must have values that are numbers, since plus adds numbers. Other functions use different kinds of data for their arguments. I think I'm going to go for about an hour. Yeah. For example, the concat function links together or unites two or more strings of text to produce a string. The arguments are strings, concatenating the two character strings A, B, C and DEF produces a single string ABCDEF. This can be seen by evaluating the following. So concat ABCDEF. Okay. And then what if I pass it number? Will this give us ABC2, or will it throw an error, or will it do something else? Let's find out. Ah, interesting. Okay, it throws an error. Wow. Okay, I was kind of expecting it to give us ABC D2 or whatever. Yeah, interesting. The value produced by evaluating this expression is ABCDEF. A function such as substring uses both a string and numbers as arguments. The function returns a part of the string, a substring of the first argument. This function takes 3 arguments. Its first argument is the string of characters. The second and third arguments are numbers that indicate the beginning inclusive and end exclusive. Okay, I just zoned out. A function such as substring uses both a string and numbers as arguments. The function returns a part of the string, a substring of the first argument. This function takes 3 arguments. What? Okay. This function takes 3 arguments. Its first argument is the string of characters. The second and third arguments are numbers that indicate the beginning, inclusive, and end exclusive of the substring. The numbers are a count of the numbers of characters, including spaces and punctuation, for the beginning of the string. Note that the characters in a string are numbered from 0, not 1. For example, if you evaluate the following substring, the quick brown fox jumped, 16, 19, you will see fox appear in the echo area. The arguments of the string and the 2 numbers. Not quite sure what happened there. Okay, you will see fox appear in the end. Note that the string passed to substring is a single atom, even though it is made up of several words separated by spaces. Lisp counts everything between the 2 quotation marks as part of the string, including the spaces. You can think of the substring function as a kind of atom smasher, since it takes an otherwise divisible atom and extracts a part. However, substring is only able to extract a substring from an argument that is a string, not from another type of atom, such as number or symbol. Okay. Bloody hell, I am hot. It is really hard to concentrate. An argument can be a symbol that returns a value when it is... Mosquito just bit me. An argument can be a symbol that returns a value when it is evaluated. For example, when the symbol fill column by itself is evaluated, it returns a number. An argument can be a symbol that returns a value when it is evaluated. For example, when the symbol fill column by itself is evaluated, it returns a number. This number can be used in an addition. Position the cursor after the following expression and type Ctrl-X, Ctrl-E. Oh? What's going on? What did I press? So I guess fill column is 70. The value will be a number 2 more than what you get by evaluating fill column alone. For me, this is 74 because my value of full column is 72. As we have just seen, an argument can be a symbol that returns a value when evaluated. In addition, an argument can be a list that returns a value when it is evaluated. Yes, okay, that makes sense. For example, in the following expression, the arguments to the function concat are the strings the and red foxes and the list number 2 string plus 2 fill column. Concat the number 2 string, the number 2 string plus 2 fill column, red foxes. Yes, okay. Red foxes, yep. If you evaluate this expression and if, as with my Emacs fill column evaluates to 72, the 74 red foxes will appear in the echo area. Note that you must put spaces after the word the and before the word red, so they will appear in the final string. The function number 2 string converts the integer, the additional function returns to a string. Number 2 string is also known as int to string. Okay, this is all pretty simple stuff. I think I get it. Some functions such as concat, plus, or times take any number of arguments. The times is a symbol for multiplication. This can be seen by evaluating each of the following expressions in the usual way. What you will see in the echo area is printed in this text after blah blah blah, which you may read as evaluates to. In the first set, the functions have no arguments. Plus evaluates to 0, times evaluates to 1. That's kind of interesting. That's kind of weird. Does it really? Yeah, 1. If anybody has any inkling as to why that is, let me know. In the first set, the functions have no arguments. Okay, yep. In this set, the functions have 1 argument each. Plus 3 evaluates to 3, times 3 evaluates to 3. Weird. In this set, the functions have 3 arguments each. Using the wrong type object as an argument. When a function is passed an argument of the wrong type, the Lisp interpreter produces an error message. For example, the plus function expects the values of its arguments to be numbers. As an experiment, we can pass it the quoted symbol hello instead of a number, position the cursor after the following expression and type. We already did that. I don't think we need to continue. When you do this, you will generate an error message. What has happened is that plus has tried to add the 2 to the value returned by hello. Okay, so if you put a quote straight after a single non-list argument, then it returns its value, I think. So fill column, that gives me 70. And if I put a quote in front of it, that gives me fill column. Interesting. Okay. So I guess hello in this example isn't actually a string. Yes, the value returned by hello is the symbol hello, not a number. Only numbers can be added, so it returns, if you put that in front of a symbol, you get the symbol back. So single apostrophe and listless symbols. So a single apostrophe, just as a single apostrophe in front of a list returns the list. So does a single apostrophe before a symbol return the symbol. I think I'm phrasing that correctly. So we're at the half-hour mark already. Time flies when you're having fun. So when you do this, you will generate an error message. As usual, the error message tries to be helpful and makes sense after you learn how to read it. The first part of the error message is straightforward. It says wrong type argument. Yep. Next comes the mysterious jargon word number or marker P. This word is trying to tell you what kind of argument the plus expected. Symbol number or marker P says that the Lisp interpreter is trying to determine whether the information presented it, the value of the argument, is a number or a marker, a special object representing a buffer position. What it does is test to see whether the plus is being given numbers to add. It also tests to see whether the argument is something called a marker, which is a specific feature of Emacs Lisp. In Emacs, locations in a buffer are recorded as markers. When the mark is set with the control @ or control space command, its position is kept as a marker. The mark can be considered a number, the number of characters the location is from the beginning of the buffer. Okay. In Emacs Lisp, plus can be used to add the numeric value of marker positions as numbers. So markers are considered similar to numbers, specifically the number of characters from the beginning of the buffer. The buffer. It's kind of interesting. So it makes sense that that's only in Emacs Lisp because that's a very Emacs specific thing. So the P of number of marker P is the embodiment of a practice started in the early days of Lisp programming. The P stands for predicate. In the jargon used by the early Lisp researchers, a predicate refers to a function to determine whether some property is true or false. So the P tells us that number or marker P is the name of a function that determines whether it is true or false that the argument supplied is a number or a marker. Other Lisp symbols that end in P include 0p, a function that tests whether its argument has a value of 0, and listp, a function that tests whether its argument is a list. Finally, the last part of the error message is the symbol hello. Well, that's kind of interesting. Functions which contain a p at the end for predicate are used to test whether their argument is a certain type or value. This is the value of the argument that was passed to plus. If the addition had been passed the correct type of object, the value passed would have been a number, such as 37, rather than a symbol like hello. But then you would not have got the error message. Okay. Quote hello is an expansion of the abbreviation hello. Okay. Yeah, I don't necessarily need to remember that, I don't think. Oh, it's hot. It's really hot. I have some Powerade. Okay, so I forgot to put the Powerade in the freezer, so I'm not supposed to have any more sugar today, but I'm gonna break the rules a little bit here. I'm gonna have another icy pole. I'm gonna have a red one this time, because that's how I roll. It's just too hot, too damn hot. Alright. I apologize if the sounds of me eating an icy pole are not very pleasant. Like plus, the message function takes a variable number of arguments. It is used to send messages to the user and is so useful that we will describe it here. A message is printed in the echo area. For example, you can print a message in your echo area by evaluating the following list. This message appears in the echo area. Let's give it a shot. It has the quotes. Interesting. Note that in this example the message itself will appear in the echo area within double quotes. That is because you see the value returned by the message function. In most cases of message and programs that you write, the text will be printed in the echo area as a side effect without the quotes. See multiply by 7 in detail for an example of this. Let's test this out. Message. So I think this is going to give me just a number 6 in the echo area. So let's try. Yeah. Okay, didn't like that. Okay, so it has to be a string. Okay. So we already just learnt about number 2 string. I think that's what it was called. And it returned 6, and it returned it within the double quotation marks, which is not what this just told us to expect. So yeah, I don't quite understand that. We could look into multiply by 7, but I think we'll get to that later. Okay, so I'll write myself a note in a minute. I'm just going to take a quick break to enjoy this icy pole. Okay, so I just checked my calories for the day in MyFitnessPal, and I didn't meet my goal. In fact, I really exceeded it. However, I'd still lose weight if I had this many calories each day, apparently, so that's encouraging. Alright. However, if there is a percentage sign %s in the quoted string of characters, the message function does not print the quoted string, the percentage mark %s as such, but looks to the argument that follows the string. It evaluates the second argument and prints the value at the location in the string where the percentage %s is. You can see this by positioning the cursor after the following expression and typing Control X, Control E. Message: the name of this buffer is buffer name. Whoops. Cancel that. The name of this buffer is info. In info, the name of this buffer is info will appear in the echo area. The function buffer name returns the name of the buffer as a string, which the message function inserts in place of. Okay, so let's try that. Let's evaluate buffer name. Okay, I didn't like that. Void variable. So do I have to put it in a string? In a list, I mean. Yes, apparently I do. It just echoed scratch to the buffer, to the echo line. The echo area is what it's called. Okay, in info, the name of this buffer is blah blah blah. To print a value as an integer, use %d in the same way as %s. For example, to print a message in the echo area that states the value of the fill column, evaluate the following. So the value of fill column is %d blah 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 fill column. If I got that right, is 70. And then I should just be able to put any number here, right? 4. Yeah. Okay. That's cool. If there is more than one %s in the quoted string, the value of the first argument following the quoted string is printed at the location of the first %s. The value of the second argument is printed at the location of the second %s, and so on. For example, if you evaluate the following message, there are %d, %s in the office. Minus fill column 14 pink elephants. A rather whimsical message will appear in your echo area. On my system it says there are 58 pink elephants in the office. The expression minus fill column 14 is evaluated and the resulting number is inserted in place of the d in the string in double quotation marks. Pink element is treated as a single argument and inserted in place of the %s. That is to say, a string between double quotes evaluates to itself like a number. Finally, here is a somewhat complex example that not only illustrates the computation of a number, but also shows how you can use an expression within an expression to generate the text that is substituted for %s. Message: he saw %d, %s, minus fill column 32, concat red substring the quick brown foxes jumped 16 to 21, and add leaping. So okay, that's pretty wild. So He saw 38 red foxes leaping. Okay. This example message has 3 arguments. The string he saw, %d, %s, the expression negative fill column 32, and the expression beginning with the function concat. The value resulting from the evaluation of negative fill column 32 is inserted in place of the %d, and the value returned by the expression beginning with concat is inserted in place of the %s. When your fill column is 70 and you evaluate the expression, the message he saw 38 red foxes leaping appears in your echo area. Actually, you can use %s to print a number. It is non-specific. %d prints only the part of a number left of a decimal point and not anything that is not a number. So I'm interested in what that means. So this is a number. D. And then the second argument should be number 2.1. Now I'm predicting, if I understood that correctly, that this is going to just print 2. And it indeed did. And if I switch this to S, I expect it to print 2.1. And it did. Interesting. Okay. It's hot. Alright. There are several ways by which a variable can be given a value. One of the ways is to use either the function set or the function setQ. Another way is to use let. The jargon for this process is to bind a variable to a value. The following sections not only describe how set and setQ work, but also illustrate how arguments are passed. Oh, it's really hot. I'm gonna go for until the hour and 10-minute mark because I took a 10-minute break-ish to heat that icy pole, but I am suffering right now. It is so hot. Really hot. I'm just drinking tons of water and I haven't needed to go to the bathroom once. Alright, setting the value of a variable. There are several ways by which a variable can be given a value. One of the ways is to use either the function set or the function setQ. See, I'm rereading this, I didn't even remember it. Alright, using set. To set the value of the symbol flowers to the list rose, violet, daisy, buttercup. Evaluate the following expression by positioning the cursor after the expression and typing Control-X, Control-E. Set flowers, rose, violet, daisy, buttercup. So this will set it to a list. Yes, okay. The list rose, violet, daisy, buttercup will appear in the echo area. This is what is returned by the set function. As a side effect, the symbol flowers is bound to the list. That is, the symbol flowers, which can be viewed as a variable. That's an interesting way to put it. Which can be viewed as a variable. Is given the list as its value. This process, by the way, illustrates how a side effect to the Lisp interpreter setting the value can be the primary effect that we humans are interested in. This is because every Lisp function must return a value if it does not get an error, but it will only have a side effect if it is designed to have one. Okay. After evaluating the set expression, you can evaluate the symbol flowers and it will return the value you just set. Here's the symbol. Place your cursor after it and type Control-X, Control-E. I don't even think I have to do that. I can just go here. except that's quoted. Yeah, so that just returns flowers. I thought so. But this not quoted version will return the list. Yes, okay. When you evaluate flowers, the list rose, violet, daisy, buttercup appears in the echo area. Incidentally, if you evaluate quote flowers, the variable with a quote in front of it that you'll see in the echo area is the symbol itself, flowers. Here's a quoted symbol, so you can try this. So I already did that. Note also that when you use set, you need to quote both arguments to set unless you want them evaluated. Since we do not want either argument evaluated, neither the variable flowers nor the list both are quoted. Oh, I see. Yep. When you use set without quoting its first argument, the first argument is evaluated before anything is done. If you did this, flowers did not have a value already, you would get an error message that the symbol's value as variable is void. On the other hand, if flowers did return a value after it was evaluated, the set would attempt to set the value that was returned. A situation where this is the right thing for the function to do, but such situations are rare. Interesting. Oh my gosh. It's so hot. It's so hard to concentrate right now. I just feel like disgusting in this chair. As a practical matter, you almost always quote the first argument to set. The combination of set and a quoted first argument is so common that it has its own name, the special form setQ. This special form is just like set, except that the first argument is quoted automatically, so you don't need to type the quote mark yourself. Also, as an added convenience, setQ permits you to set several different variables to different values all in one expression. To set the value of the variable carnivores to the list lion, tiger, leopard. So this is, I really should have typed this as a question. What is the difference between set and setQ? Because I was asking myself that as I was reading. And that's a to do, but I already have it done for it. So in set, the first argument is evaluated unless it has a quote before it. In setQ, the argument is automatically quoted. That should be automatically quoted. setQ can also take multiple arguments. Okay. Set the value of the variable carnivores to the list lion, tiger, leopard using setQ. The following expression is used. setQ carnivores, quote, lion, tiger, leopard. This is exactly the same as using set, except the first argument is automatically quoted by setQ. Q in setQ means quote. That was pretty intuitive. With set, the expression would look like this. Set, quote, carnivores, quote, lion, tiger, leopard. Also, setQ can be used to assign different values to different variables. The first argument is bound to the value of the second argument, the third argument is bound to the value of the fourth argument, and so on. Oh, okay, that's interesting. For example, you could use the following to assign a list of trees to the symbol trees and a list of herbivores to the symbol herbivores. setQ trees, pine, fir, oak, maple, herbivores, gazelle, antelope, zebra. The expression could just as well have been on one line, but it might not have fit on a page. Humans find it easier to read nicely formatted lists. I wonder what this returns. It returns the last list. Okay. Although I've been using the term assign, there is another way of thinking about the workings of set and setQ, and that is to say that set and setQ make the symbol point to the list. This latter way of thinking is very common, and in forthcoming chapters we shall come upon at least one symbol that has pointer as part of its name. The name is chosen because the symbol has a value, specifically a list, attached to it, or expressed another way, the symbol is set to point to the list. Okay. Oh gosh. Oh man, it's reached that point where I just want to quit. But I'm going to push through for 10 more minutes. 10 agonizing minutes. And then I'm done. What's the time? Oh, we're right on 10:30. Like right on the hour. Nope, I'm not going to use an excuse. So I'm going to keep going until 10:40, and then I'll go for maybe a 20-minute walk, and then we'll be back on the hour, and so there's no excuse. Yeah, so I'm going to keep going for another 10 minutes. Here is an example that shows how to use setQ in a counter. You might use this to count how many times a part of your program repeats itself. First, set a variable to 0, then add 1 to the number each time the program repeats itself. To do this, you need a variable that serves as a counter and two expressions, an initial setQ expression that sets the counter variable to 0, and a second setQ expression that increments the number each time it is evaluated. So setQ counter 0, setQ counter plus counter 1. Counter. Text following the semicolon or comments. See change of function definition. So set q. So so that returns 0. Boop boo. That returns 1. And then this should also return 1. Yeah, it does. But then if I go here, we get return 2, and then if I go here, I get return 2. Okay. So this is returning. setQ returns the value of counter. So it actually, previously it wasn't actually returning the final list, it was returning the value of the final assignment, final symbol. Okay. If you evaluate the first of these expressions, the initializer, setQ counter 0, and then evaluate the third expression, counter, the number 0 will appear in the echo area. If then evaluate the second expression, the incrementer setQ counter plus counter 1, the counter will get the value of 1. So if you again evaluate counter, the number 1 will appear in the echo area. Each time you evaluate the second expression, the value of the counter will be incremented. When you evaluate the incrementer, the Lisp interpreter first evaluates the innermost list. This is the addition. In order to evaluate this list, it must evaluate the variable counter and the number 1. When it evaluates the variable counter, it receives its current value. It passes this value and the number 1 to the plus, which adds them together. The sum is then returned as the value of the inner list and passed to the setQ, which sets the variable counter to this new value. Thus, the value of the variable counter is changed. Summary. So perhaps I'll end after we've finished this section, this list processing section. So learning Lisp is like climbing a hill in which the first part is the steepest. You have now climbed the most difficult part. What remains becomes easier as you progress onwards. Summary: Lisp programs are made up of expressions which are lists or single atoms. Lists are made up of 0 or more atoms or inner lists, separated by white space and surrounded by parentheses. A list can be empty. Atoms are multi-character symbols like forward paragraph, single character symbols like plus, strings of characters between double quotation marks or numbers. Number evaluates to itself. String between double quotes also evaluates to itself. When you evaluate a symbol by itself, its value is returned. When you evaluate a list, the Lisp interpreter looks at the first symbol in the list and then at the function definition bound to that symbol. When you evaluate a list, the Lisp interpreter looks at the first symbol in the list and then at the function definition bound to that list. Then the instructions in the function definition are carried out, with the subsequent values in the list, the subsequent symbols in the list being passed as arguments. It should say, a single quote tells the Lisp interpreter that it should return the following expression as written and not evaluate it as it would if the quote were not there. Arguments are the information passed to a function. Arguments are the information passed to a function. The arguments to a function are computed by evaluating the rest of the elements of the list, of which the function is the first element. So that's what I said before. A function always returns a value when it is evaluated, unless it gets an error. In addition, it may also carry out some action that is a side effect. In many cases, a function's primary purpose is to create a side effect. This is kind of interesting. So this isn't sort of what I thought of functional program being. Maybe it's mostly functional. I always thought that in functional programming, that there were no variables. For example, that everything was a function. I guess that doesn't make sense, because even in pure mathematics you have algebraic variables, I guess you could say. But that's what I always sort of imagined. I didn't think there were these side effects, and I didn't think there were variables. So it's kind of interesting. Okay, so we got some exercises. All right. A few simple exercises. Generate an error message by evaluating an appropriate symbol that is not within parentheses. An appropriate symbol. I don't quite know what it means by that, but okay. Cool. I don't know if I did the right thing or not there. Generate an error message by evaluating an appropriate symbol that is between parentheses. I guess I did that. Create a counter that increments by 2 rather than 1. So set q counter 0. Set q counter plus counter to counter. Whoops. So I've always got to go to the end of the S expression. So now counter is 0. Now it's 2. Now it's 3. Now it's 4. That's 10, 12, 14, 16. And then if I evaluate it, I get an error because I need to quote it. Is that it? Then I just get counter. I need to unquote it because it's a number. Yeah, okay, so 16. Alright. Alright, so this is probably the place to stop because we're about 3.5 minutes from my second goal that I set, and we just finished a section and I'm ready to lose my mind. So I'm going to try and remember some of the stuff we learned today. So so we learned about set and set q. So set q just gives an automatic quotation mark. That's to avoid evaluating the first argument. Also set q can set more than one symbol. Set q returns the value of the last assigned symbol. Markers are like a number. They're the number of characters from the start of the buffer. think those are the main important things. If there's anything I forgot, remind me. So what I'm going to do now is I'm going to kill those. And I'm going to kill this stream. So thanks for anybody who hung around. I know I'm not the biggest entertainer right now. I'm pretty warm. So I hope you guys don't mind too much. Yeah, it was a bit of a chore today. So what I'm going to do after I've had my walk is I'm going to stream my use of Ninchanese, which is a Chinese learning site. It's kind of a mix of an SRS and a language course and a sort of adventure game. So you guys can have a look at that. It's sort of in beta. I think they're sort of bringing it out of beta now. But it still feels a little bit like beta. But however, having said that, it was good enough that I was happy to pay money for it. So I don't want to sell it short. It's a good product. So in about 20 minutes, I'm going to be streaming that, and there'll be a whole new stream. I haven't streamed that before, so that's exciting. Anyway, guys, thanks for tagging along. I hope it wasn't too boring. If you guys have any questions, leave a comment. If you enjoyed the stream, leave a like. If you want to get in touch with me on Twitter, I do have a Twitter account. It's easy enough to find, polymathpraxis at the moment. I don't really post on there yet, but I will be. And I do check it just in case somebody wants to at me or whatever. So anyway, guys, I will catch you later.